Hello. So anyways, we're going to do the data science, and we're going to look into the mononucleosis one. I was itching stuff off my face. Oh my god, yeah, wasn't really feeling that great. This light's terrible. So this is the trailer. Inside the trailer. All right, so I'm going to share my screen, and we're going to go ahead and go. Yeah, some creep was sitting there with their unmanned aerial motorcraft. Earlier, I called the police, waiting for them to respond. I think I saw a guy who looked suspicious, an old Hispanic guy with white hair, obese, not mortally obese, about early 60s. So he had a blue bag about the size that could hold one of those unmanned aerial motorcraft drones. This fucking idiot, I don't know if it's him, but he looks very suspicious with that bag, like he is up to something. He was spying on me in my bathroom in the window. He's a fucking creep. So I'm gonna see. I might get the video for that guy. I have a couple different angles. Anyhow, let's go ahead, and I'm gonna go ahead and show my screen. I'm sharing the screen, so we're gonna go to this file. I think it's here because I just found it. I was looking it up. It's also an old one. It's not as old as the autism one, but it's still older. It's 2017. The autism one was 2009. So this one is transcriptome profiling reveals major cell types in the cellular immune response against acute and chronic active Epstein-Barr virus infection. Expression profiling by array. Epstein-Barr virus is a common human pathogen that infects over 95% of the population worldwide. In the present study, the whole transcriptome microarray data were generated from peripheral blood mononuclear cells from Chinese children with acute infectious mononucleosis, or AIM, and chronic active EBV infection, or CAEBV, that were also compared with a publicly available microarray data set from a study of American college students with AIM. Our study characterized for the first time a broad spectrum of molecular signatures in AIM and CAEBV. The key findings from the transcriptome profiling were validated with quality polymerase chain reaction and flow cytometry assays. The most important finding in our study is the discovery of predominant, it looks like gamma tau. I don't know what that is. Anyhow, TCR expression and gamma tau, I'm just going to call it that. T cell expansion in AIM. This finding, in combination with the striking upregulation of CD3, CD8, and CD94, suggests that CD8 plus T cells and CD94 plus NK cells may play a major role in AIM. Moreover, the unique upregulation of CD64AB and its significant correlation with the monocyte marker CD14 was observed in CAEBV, and that implies an important role of monocytes in CAEBV. So never let monkeys eat bananas is neutrophils, lymphocytes, monocytes. These are all the white blood cells, eosinophils, and basophils. Monocytes, eosinophils, and neutrophils are the natural killer cells. Basophils, eosinophils, and neutrophils are the granulocytes. So they go out and they inject granulocytes in, and they burst the pathogen. Or, I think that's what they do. Something like that. And then those are all white blood cells. And then, in conclusion, our study reveals major cell types, particularly the gamma tau T cells, in the host cellular immune response against AIM and CAEBV. Total RNAs were extracted from peripheral blood mononuclear cells from 6 acute infectious mononucleosis, AIM, 5 chronic active EBV infection, and 6 healthy controls. Differential expression was assessed using the R package lemma, and pathway enrichment was performed using the R package gauge. Expression signal correlation with 36 blood cell markers was defined by all right. Okay, so it was at like 5 p.m. Just making a note. Okay, so here, this is just a print screen too, so I can't go into these links, but it tells you what it is. These are CEL files too, so we're gonna go ahead and go to this folder, and then let's just extract this. Okay. Oh, okay. Yeah, so it's actually a lot of. Is that Arkansas? All right. It looks like we're gonna be. Oh, how fun. Okay, so just extract this, and I forget how I use the CEL files to begin with, but I think I'm just gonna go ahead and start these. I'm pretty sure I just need the CEL files, so I'll go ahead and do that. So let me see what this one is. I haven't used these ones before. Gene full chip. Oh, and then you have to match it to the project. Okay, that's fine. So we'll go ahead and do that. Go ahead and put all of these CEL files in one folder though, and then extract them and remove them. But okay, so we got 1703. Now I'll do this one. Um, 2293. We got that one, so now we'll do the 2295. We did the 2295. Now we'll do the 2386. And now we'll do the 2407. It's not that many files, so it's fine. It's certainly more convenient when you don't have to do this additional work, but that's okay. I'm here to take a break from my dogs. They're a little bit better, but they're still loud. We're just going to continue doing this until we get all the CEL files. So far we have all the CEL files. So now we can just put this in a different file. Let's move it up and put the CEL files. Oh. Okay. So we'll go back here. Control C. Copy. We'll shift. Select. Oh, control, not select that one. And then we'll control C, copy. And go here. Paste on. All right. And then let's go ahead and extract this one, the series file. Okay. All right, so I'm going to rename this folder. And then I'll just copy this and paste it. So we have that. Wondering if I should look up the gene. Okay. Let's go back to. Okay, let's go back to this. I want to see if there's a platform I need to use with this. Oh, GPL 17586. Okay. So we'll go ahead and go to the what is it? GPL 17586. We have to copy that one too. Let's see. Actually, let me clear my cache. Actually, okay. We're handling other calls. Alright, so it is GPL 17586. I'll just search that. Let me go to a different one. Okay, so I cleared that. Let's go ahead and it's GPL. What did we say it was? 17586. Huh. Alright, let's go to all databases and search. And alright, I feel like we're gonna need this, so I'm gonna go ahead and download this. Okay, hold on, where's that? This is GPL 17586. Okay. So we'll go ahead and download the full table. Let's try to understand. There's the ID. Or doing that. I'm gonna go to alright. Go ahead and go to our downloads. We'll get that, copy and paste it in to this folder on mononucleosis. All right, and now we're going to go ahead and open our studio and start our file. Alright, we'll close out of this. This is a different work environment. I'm going to go to that folder we're working in. We'll set this as our working directory. We're going to make a new markdown file. This is going to be mononucleosis, AIM, acute infectious mononucleosis, and chronic, what did they call it? Chronic PBV. Okay. GSE 599. 2017 study. All right, let's do that. Let's go ahead and clear all those. This study is GSE 85599 using CPL files and total RNA. Acute, infectious, mononucleosis, and chronic few cells. This is a platform. So we will be combining the CPL files with the platform and using our previous project on autism to work this similar way. Okay. Let's go ahead and add some chunks. And then let's save it. It's going to ask us for our name. We're saving it as GSE 85599. Mononucleosis and chronic PBV. Children and teens. Okay. 2017 study. Okay. Now, let's go ahead and files real quick. Where's the one? I downloaded this one. What? Okay. Let's go ahead and read in the series information. Oh, geez. And then we'll see it's going to. Line 67 did not have two elements, so we're going to read in rows equal. Let's try 66 first, and let's change this to 66. Let's see what we have here. Okay, it's total RNA. Here's a summary. Chronic active Epstein-Barr Virus. Okay, so right here we see that there's a problem, and we're just gonna read in 31 rows for this one. So let's go ahead and read in 31 rows. I'll remove the series 66. We'll just do this again. That isn't clear. I'll do that, and we'll skip 31. See what happens. Line 36 did not have 18 elements. Skip 31. In row equals 35. There. Okay. Here we go. This looks better, much better. This is their series data. Okay, so it has the sample ID and then it has the type, peripheral blood cells, peripheral blood mononuclear cells. This is the acute infectious mononucleosis. Acute infectious mono, AIM, AIM. And then we got a chronic active EBV and AIM, chronic active EBV. So here we are with all this information. Now we have to get the gene expression. We have this, so we're just going to save it as it is. That's our series information. Let's go ahead and let's make another chunk and read in the libraries, because we didn't make that one. We're only using that one for now. And then we'll use the page table series. Okay. And just so we know, weird today. All right, so we got the series information. Now I'm gonna have to go into that autism file and see how we got the how we were able to retrieve this. Because I'm pretty sure it was this one. Okay. All right. So I'm just reading over this. Files and zip mail folders. Set working directory path and stop files. Oh, this one's not the one that we use CEL. There was another one we use CEL in. We're gonna just go look for it. These are the MEV files. It was the one before this. So we'll go to that one. I think that one was. Well, actually, let's just look. It's a large B cell, so we'll go ahead and go to that. I think it was in this one. We're not going to make any changes to it, but I do recall how we did everything, so we're going to go back to this one. Okay, we're going to, okay, I tried a whole bunch of different things, so alright. Okay. I think I have these ones, so let's go ahead. We're going to need the AFI and Oligo packages. Let's remember which one works. The option B using Oligo, library Oligo, get geosub files. This uses a temp2 version of placing each CL file from individual folder into one folder names. Get geosub files. So went ahead and put each file from the CEL folder in its own folder. So we're going to go to the desktop. We're going to go back to our folder. We have the CEL files, but each one is actually in its own folder. So I'll go ahead and let's copy and paste each of these. We'll just paste it here. Oh, shoot. Because there's this folder name that we can't place it here. So we're going to go ahead and put a new folder here. And it's going to be files CL. All right. And then we'll just go down the list. There's not that many, so it's not too bad. I'm just copying and pasting these into its own folder. Oh, we already copied that one. All right. It's a fucking sicko around here, dude. Spying on people. It's not business what anyone's doing. He's coming off like a fucking sicko because he probably is. There we go. He needs to mind his own business and stop creeping everybody out. Yeah, if it was the backcountries, he'll be shooting that down. There you go. Come here like a man and ask for it. Ha. You invaded my privacy. That is a law that you broke. The eavesdropping law plus stalking. Okay. breaking and entering because you don't have vision to see that, and you're looking in there, seeing them. Intimidation, coercion. Let's go ahead and make some other connections here. Right. Let's go ahead and cut this folder, and then we're going to go ahead and paste it here. File CEL, that's what we called it. All right. So now I'm going to see if we have this one. I'm going to run this code just to see if we have it. Okay. Looks like we do. So now I'm going to put that in the chunk. We'll go to history. Come on. And we'll bring this to the source. We'll just run it in here. And then we'll go to this next one. We'll run it. We'll set that to the source. And we'll run this line. And now geosub file. Get geo. That was the name of. Get geo. Oh. Okay, so I'm gonna go ahead and copy this. I'm gonna put it right here. And then our file is 85599. I think I had a folder there though that was named that. So let's go ahead and call this file CEL. Because we'll see if it needs that folder first. There before. Yeah, see, look at this, 43 p.m. So it added this folder on my. It's still running, so got a stop sign right here. So, yeah, it has these folders here. This one, it's still doing whatever it's doing. Hold on. All right. So as soon as that's in there, we'll go to untar. Okay. List.cel files. .cel files. It says data. Summer Studio. First person instructor corrections effective action made for her. Normalized data. No data. It's following an online tutorial to do this. The bioinformatician. Alright, now let's go to another one. Pretty sure that guy is the one that was. Oh, it looks like it did something new. Alright, good. So it's there. Just see about geo query, get geo subfiles, and then we're gonna untar and then read in. So let's copy and paste this. Control C copy. Go to our folder. Control V paste. Now we're gonna go into. We don't have a folder that has that in it, right? And there's our raw one. Oh, okay. I guess it went ahead and did that, so we'll just do it just like it's doing it. So we go, that's what we did, where it went. So now we have to run that next line of code. Just run it. Warning. Oh, yeah, because we don't have that file. It has to be 85,599. Okay. 9. GSE 85,599. Now let's run it. Okay. Now we're going to go here. 85,599. All the CEL files must be of the same type. List.cel files. Okay. Let's see if it does it. CEL files. We'll run this line. Character 0. And then it says at the same type. This. So we'll go here and then look he's talking about. Let's just read it from here. Let's see if it reads it from here. File CEL. Read.cel files. List.cel files. Okay. We're going to go to this folder. Was it file CEL though? Yes, file CEL. Oh. Okay, so that's what we did. Copied and pasted them earlier. Now let's read these files in. Let's save this. Let's go to this one. After reading in these files, we're going to inspect it. Now I'm going to switch to good. I can see the arrows now. That's awesome. So after doing and then we'll normalize the data. Oh, whoa. What? Hold on a second. What is this? What is this from? Okay. So I have a problem with a package for reading in these CEL files because I had to remove all this information because of the McAfee, and I had a certain way of installing it. Maybe it's on here or what happened. The rest works after correcting for the package for my version R, but near stops working right here. Okay, so to do that one, loading required package, attempting to obtain from bioconductor. Replaces my now. Okay, see halt, cran, get options, repos. Simple warning and download file. So I need to get this file, and it has to be for my version of bioconductor. So it's going to be this PDHTA 2.0. We have to go over and look for it. A bioconductor. Alright. Okay. For release 3.23, how do I find my version? Okay. How to get my version of bioconductor in R. BioC manager install version equals. One second. BioC Manager version. Okay. Let's just go over here. Let's just make a separate one right here just to see what it is. BioC Manager version. Okay. 3.23. I need the package for my version of bioconductor 3.23. See. Let's go over there. BioC Manager install PDHT. Is to install this. Okay, so which version is this for? 3.23. That's the one I have. Right, 3.23. Okay. So I need to copy this code. Copy. And then I need to run it. Control A paste. Do it right here. I don't know if I am. Okay, so it's downloading it. We'll see if this works, and then we'll run this code line right here. He's fighting. We'll run that code afterwards. Still running. Still running. Okay. So we want to get this sample ID, and then we'll also get the diagnosis. So the 12th row and the first column, just so we know what our headers are. I'll go ahead and we'll go ahead and look at the let's just do that. Information for the sample IDs and the sample type as EAM or chronic acute EBV. We'll just go and look. So it is the first through, and the 12th. We want the first and 12th rows. Sample information. It's going to be series 1 and 12 for the rows, and then all the columns. And then let's look at what we got. All right. Okay. And then let's just use column 2 to 17, or 2 to 18. And we'll use page 2. Oh, and there's some healthy ones. Okay. So let's go ahead and look at our header. Okay. Column names normalized.expr. Okay. So let's go ahead and shoot. Okay, so column 2 through 22.7. Okay. Well, 2 through 18. We should identify as the type of sample and remove the excess information. So to do that, what is, if it starts with a reg expression. We'll have to go to the internet real quick. Regex for R to remove underscore and everything after it. Okay. Clean sub. So it's everything after this. Strings. Matches 0 or more of any character greeting. In sub, replaces the match part with an empty string. Okay, let's try that one. Okay. Column names 2 through 18 of normalized.expr. Or can a G sub the underscore a dot asterisk for nothing, and we put this isn't just the vector we're doing that to. G sub. Okay. Let's see if it does it. Good, it did. All right, awesome. So now we're going to look at the sample type. Okay. So, sample information. Okay, so sample information, and we will find sample information. Oh, actually, let's transpose it. Sample info. Okay. Let's make sure that's the same order. It's 3, 4, 5, 6, 7, 8, 9, 31. 2, 3, 4, 5, 6, 7, 8. Okay. Now let's go here. Okay, so let's go ahead and G sub diagnosis out of that. Alright. X12. Alright. Sample info by X12. Okay, actually, let's do the grep first. AIM. Grep. AIM. Sample info by X12. And then CAEBV. Grep. CAEBV. Sample info by X12. And then healthy. Grep. Healthy. Sample info by X12. Okay. Now we're gonna go sample info AIM. Oh wait, by X12. AIM in brackets. And we're gonna put AI acute oh no. Hold on. AIM. Acute infectious mono. Yeah, because these are going to be the column name headers. Sample info by X12. CAEBV. CAEBV. Sample info by X12. Healthy. Healthy. Okay. Let's run this. And let's look at this table. Okay, that's right. Okay. So now we're going to paste. Oh, actually, let's go ahead and just... for our colonies. So this we're going to okay. All right. Let's do. Okay, let's create another column. Sample. Oh, info by samples. Oh shit, I'm running out of energy. All right, hold on. I'll have to use this battery. Okay. Oh no. I'll just. Here we go. Oh. And then we'll go sample input by samples. It's gonna be piece x1. Wait. Sample info by x1. Sample info by x12. Separator equals underscore. Let's see if that works. Okay. We will sample info by samples. Select one. Only data frames can be used to create a page table. Oh, oops. I don't know. I did that. All right, cool. So we're gonna do this. We're gonna name our columns of normalized.expr by the samples. And it was 2 to 18, right? Okay. Column names normalized.expr 2 to 18 equals sample info by samples. Let's make sure it's 2 to 18. Yeah, it's 2 to 18. And then we'll look at the column names of normalized.expr. All right, good. So that's what we're going to do. Let's leave this class feature there, though, for X12. Samples. Let's call that the class. Okay. Class is samples info by X12. Sample info. Okay, good. There's 17 samples, and that's when we do the random forest. Okay, to do a prediction by class. Let's get the full change values though. So we have our data. I'm pretty sure we don't need this anymore. Okay. Yeah, I'm gonna say we don't. Okay. So let's write this out though. Normalize that expr. To read in later. Mononucleosis and active PBMC. Chronic active PBMC. Infectious. Acute mononucleosis and active EBV. Genes. .csv. Row.names equal false. Okay. So I'm gonna write that out. Let's look at what we have then. So we have the IDs, we have the genes in here. Let's see if we can take that gene now, though, by using regular expressions. And the second. To select the second item in a list between brackets. Is it that one? Yeah. It's getting cold now. Oh, got it. Oh. Yeah. Cool. All right. Okay. If you want a regular expression or extract the second item between delimiters from a string, for example, if you have first, second, third, you want second. Our solution using stringer, library stringer text. This captures the second item between print second item. So first item, marks the second. Okay. So we'll just we'll go ahead and copy this. And paste it into our markdown, but not in okay. We're gonna need the library stringer. You might have to install it. Okay, good. Now we'll go ahead and we'll run this code. Text. Okay. Okay. So we are going to go ahead and copy this. from internet search to extract second listing. Contain data. Okay. And we're going to put gene. And then we're going to go string match. We're going to go normalize.expr by gene assignment. Okay, let's do that. There's 70,523, and we have 70,523. So we're going to go normalized.expr by gene, and then we'll see what we get. Well, there isn't any right there, so that makes sense that it wouldn't have it. Maybe we can like order them. Like there's a lot of anything, but there's 70,000. So we should start seeing some genes. No, nothing. It should be right here. We should be getting this one. But it's not showing anything. So maybe, hold on. Starts with, okay. It is the right brackets. Starts with this. Everything between it ends with that. And then maybe I don't need this. There. Oh, jeez. All right, that's not working. All right. Well, that one didn't work. Stringer. That is the second. Okay, something. The first one. Okay. Okay. Match the first started string. Okay. Match the first double brackets. Match any characters except first item. Match the second. Capture group for the second item until next. If you have multiple strings. Okay, it starts with that. Well, it's not working, so let's go ahead and that is not what we wanted. And actually it made two genes too when I did it, so it's weird. String matched. It added two of them. Wow. Okay. Well, you can see right away it's not adding that. It's not. It's the first item. Okay. All right. Well, that didn't work. Let's try another one. Let's see how long this is. Almost 2 hours. Okay. So what I want to do. Second. Okay, I want the first item. Item in a list between that. Okay. Extract the first match between match sub text. First item between is all right. String match. The first string match text. Let's try this one. One work. Another one. Try. All right, so we'll go ahead and this normalize .expr by gene string match normalize .expr by gene assignment. Let's see what it is. Did we run out? Okay, good. It looks like this one's working. All right, that's a better regex. Okay, great. Okay, cool. Awesome. Okay, let's see that. That one worked for particular expression extraction of gene. Let's get the columns we want and write this out. So for this other one that we wrote out, let's go ahead and just write over it. I'm going to cut that. Okay, but I want to use the columns that we want. So let's look at the column names real quick. Okay, we don't really need these anymore. So let's go ahead and make this data needed. Okay, and then we'll go ahead and we're gonna go normalized.expr, all the rows, but we just want the first one, and then let's go ahead and rearrange them. 19, 20, 21, and then columns 2 to 18. I'll just put a little hashtag there. Let's go ahead and run that. Okay, we'll go ahead and keep that because it has the original one. Original before gene. Oh, actually, it's not the original. And then we'll write a new one out. Data needed ML. .cs. Oh, AIM. Chronic active EBV.csv. Row.names equal false. Okay, let's put eval equals false, and then we'll just run it. So we can go ahead and start doing some machine learning on this. Predict the class of the sample as AIM, chronic active EBV, or healthy. Okay. Table of class shows how many are in our data. Okay. We have 6 acute infectious mononucleosis, 5 chronic active EBV, and 6 healthy samples. All right. So column names of data needed. All right. We don't really need the ID anymore, so the gene. Okay. The ID isn't helpful though. But we're gonna go ahead and 1 to 6, 1 to 5. Wait, you know. And the healthy. So those are already ordered for what sample it is. Let's go ahead and data needed by AIM is row means data needed, all the rows, columns, wait, AIM. Yeah. More complex. Okay. Okay, C 1, 2, 3, 17. More complex. 19 variables. Hold on. What is this? Means dims equal 1. Okay, that's the object data needed. Must be numeric or complex. Maybe is equal. Huh. I'm not sure what's going on here. Let's see. It usually works. Okay. Data by area mean. Row means. Data needed. Alright. I've had this problem before, so I'm not really sure why it's doing it, but we're gonna go over there and look and see. Okay. What is the structure of data needed? It's numeric. Okay. Column names of data needed. All right, so we're gonna go ahead and group manually. It's gonna be 1, 2, 3, 4, 5, 4, 5, 7, 16, 17, 18, and 19. Okay, good. Now, data needed by CAEBV mean row means data needed. C, and this one's going to be for okay. 4, 5, 6, 6, 8, 9, 10, 11. Okay. Things equal 1. Data needed by healthy mean row means data needed. Oops, I just saw that. I don't know. Spell that right. This one's going to be healthy. 10, 11, 12, 13, 14, 15, 16 to 17. Okay. Okay. Let's make sure it has a healthy mean. Okay, great. Now let's put a fold change. Data needed by FC healthy equals data needed by AIM mean divided by data needed by healthy mean, and then data needed by fold change CAEBV healthy. Oh, let's name that one healthy too. Both data needed by CAEBV data needed by healthy mean. Okay, let's look. Okie dokie. We'll change. Okay. Now, let's order this. Okay. Top teams. Okay, ordered. AIM ordered. Let's see. Okay. Data needed by FCA. Oh, wait. Data needed. Okay. Order data needed by AIM. Oh, that one. Yeah. Decreasing equals true. All right. And then CAEBV ordered. Needed ordered. Needed by FC healthy decreasing equals true. And then let's go AIM ordered. Wait, AIM ordered, but complete dot cases. CC. Oh, how about let's just do AIM ordered FC complete dot cases. AIM. Hello.
Hi, good evening. Am I speaking with Janice Harris?
Yes, hello. Yeah, somebody is flying around a drone and it was spying on me in my backyard, but I was in my bathroom. My dog took away the linen and it was the bathroom outside and I could see it and it hovered. I was peeing on the toilet and it just stayed there like a pervert.
Oh, yes, sir. That sounds terrible. I'm sorry to hear that. Do you know approximately how high the drone was or how close it was to you?
I could see it over the house. I would say it was probably right above the street of 7th Street and maybe up a little bit higher, twice the height of the telephone poles.
Okay, so approximately like the height of a telephone pole.
A little bit higher, though. Like if there was another telephone pole stacked on top of it.
Okay, so it's pretty significantly higher. All right, so about 2 telephone poles, you would say, roughly.
Yeah.
Okay. And also, man, do you know when this occurred?
Yeah, it was around 4:40 p.m.
Today?
Yeah.
And do you have like any inclination of who it could possibly be? Like, did you observe it go like to a certain backyard?
What? I don't really know for sure, but there was this guy walking around that I'd never seen before, but I don't really look at people walking. And he had a bag about the size of what that size of that drone was. And he was kind of looking suspicious. And it was at 5:02 p.m. because I went to my trailer. And I think he was flying it around for a while and then he let it go. But he had a blue bag he was carrying, a red polo shirt. He was slightly obese, And then he looks about early 60s to the late 50s, and he had white hair and a white beard. He was probably about 5'11" to 6 feet tall, and then he had dark skin, but I don't know if he was Mexican or black or Arab or whatever.
Okay. So, I mean, other than that, you've never seen this person before?
Never.
Okay. But, like, did you see, like, definitively, like, the drone go back to him and then he recovered the drone?
No, I just saw the guy carrying a bag the size of that drone. So I don't know if it was him. He's probably just walking around, but I never seen him before.
Okay. So I got that down here. I just also want to inform you on something. So I'm not sure if you are aware, but our department utilizes drones. Were you aware of that?
I am aware of that, and I would also like to make a complaint if it's one of your cops that are spying on me peeing in my bathroom, because there is no reason for you guys to look at me peeing in my window of my bathroom.
Right, Janice, I can definitely reassure you that that's not us or any of our technicians. Our drones only operate when necessary. So we get like a call for service and it's like extremely necessary to utilize a drone for officer safety to like observe the area. Well, that's when we'll fly the drones. Like we don't ever just fly them randomly just to like, like proactively fly around the city. It's just more of like an on-call basis. So I can definitely assure you that that's not ours. And also, too, our drones are geotagged everywhere.
Okay, great.
Wherever they go, they get tracked.
Oh, okay. Yeah, that's good. That is a good state of mind to be in, because I would hate to think that it was the cops doing that, because it was hovering around and it's circling around this whole area. So I don't really know who it was, but I would like them to stop because it's really creepy and perverted. I don't know what they're doing.
I absolutely agree with you, Janice. Like, definitely right. Like, our privacy is a sacred thing, and it's definitely challenging now the way technology is advanced, where these drones can fly around, so people can have complete anonymity and utilize these drones to do things they shouldn't. But what I can tell you, right, like for you, what I would do going forward, just make sure that you're extremely cautious. Make sure your blinds are closed. Make sure you're taking extra provisions to ensure that your privacy is still intact. As far as this situation, there isn't. The drone is definitely observed, definitely looking through your window and observing you while you're using the restroom. That's definitely a crime, right? That's invasion of privacy. Now, we just there has to be more to it. Like I need to know definitively who it is. If this guy you seen for sure it went back to him, and then who he is. Then we can address it, right? But with what we have now, it makes it really complex to actually figure out who's operating the drone. So what I can just tell you is continue to partner up with us. We love our citizens here. We love to collaborate with them and to help protect the community and keep us safe. So if you see suspicious individual again, or you believe hey, but for sure, right? We just don't want to guess and assume, because then that's situations can occur that we don't want. But if you see something definitively and you're able to report it, then I would say give us a call back and then give us that information we need so we can take action on it.
Okay, great. All right, thanks so much. Right. Yeah, I appreciate that.
You take care.
You too. Thanks. You too. Bye. Well, that's good. I got some clarity, because I literally would hate to think that was the cops doing that, but now there's a pervert out there doing that for sure. So that's not cool. All right. Anyways, we're gonna finish this. We are at where are we at? 2 hours and something. So I'll just make it 3 hours. Doesn't really matter. It's getting kind of dark out there. I think I can turn that light off, actually. All right, so we're gonna go ahead and work on this some more. All right, complete doc cases. Let's see if it does this. Let's run the selected line. No. Oh, order. Oh, actually, let's just order. Let's just do the whole chunk. Okay. And there are still the same numbers. Okay. So for the genes, all right, I want to grep the gene, the triples, the lines. Grep. And ordered, let's see, by gene. Let's see what it comes up with. Okay, there's 37,000 of those, almost 38,000. So now we're going to go ahead and go. Okay. AIM genes. AIM ordered. Let's see. Minus. Wait. Minus triples. Let's see if that does it. Okay. Looks pretty good. All right, cool. And now CAEBV genes. CAEBV ordered FC minus triples. Let's run this line. Okay. And they should both be. Okay, we can close this one. And close this one. Okay, so actually that was wrong. Okay, so triples T. CAEBV or FC by gene. Negative triples 2. All right, let's see if that works. Okay. All right, good. And then let's look at the fold change values to make sure they're in order. This one's by healthy for the the fold change for C. Chronic active. And that's like the lowest one and then the highest one. Okay. Now let's look at the AM genes. Should be ordered as well. Form yes, right here. It's ordered by this one. So we're gonna go ahead and let's take the bottom 10 and top 10 of each. Okay, so let's put the dimensions here. 30 to 670 rows. And this has 32,670 as well. Okay. And then we don't need, for our matrix, we don't need the first column and the last 1, 2, 3, 4, 5 for making the matrix. So the last 5 and first 1. Okay. All right, so AIM 20. We're gonna go AIM genes, and then we're just gonna take the first 10 and then the last 10. 61, 32, 670. And then let's just remove column for, no, actually, we'll just leave it. And then the top, CAEBV 20 is CAEBV genes. Should be 20 each. Good. 20 each. Let's look at this. All right. There's that AIM. All right. And then here is the CABV. All right. Great. And let's go ahead and make our matrix. So we're going to just use columns. Okay, so let's look at the column names. All right. Okay, so let's just, okay, fine. Column names. Genes. It's the same for both, so. So let's just use AIM MX. Let's go data.frame T transpose. And it's going to be only the 3rd to the 19th column. Transpose. Top AIM 20. Okay. Column names MX is going to be top AIM 20 by gene. And then AIM MX by class is at X data.frame T top C 20. It's going to be the same. Columns 3 to 19. Column names CAEBV MX. Top CAEBV20 by gene. CAEBV MX by class. As dot vector class. Okay, cool. Let's run that. And we'll do page table. MX. Let's just check the class. Looks like it's good. Good. Now we'll do the same for CAEBV. Okay. Now we'll go ahead and save that. But let's put in our random forest classifier. That. It's all right. 2.5 hours. Okay. We're gonna go ahead and go to Okay. So So now we're going to make a random forest EIM. Oh, actually, we got to set our seed. 1, 2, 3. Train. Let's do in train. 80% training, 20% testing, validation set. So we're going to go sample. There are 17 samples. Where's it at? 17. Okay. 17 of those. Yes. There's 16 samples. No, there's 16. What? No, there's 21. Okay, there's 20 genes. 20. Okay. But the samples are 17. Okay, yeah, the rows. Okay. So we're gonna go ahead. Sample 1 to 17 and then 0.8 times 17. Right? Okay. And then training is going to be our AIM MX in train. Testing is our AIM MX negative in train. Table training by class. Okay. All right, good. Now table testing by class. Seeing if we have every sample in each. Okay, good. It's almost balanced. There's going to be less of that, so it's probably going to have a worse outcome. Okay, now we can do our random forest classifier. EIM. Random forest training 1 to 20. Training by class. Try equals a third of 20, so it's like 7. Tree equals 5, 0, 0. Confusion equals true. Importance equals true. RF AIM by confusion. Let's see how well this did. Oh, wow. So 100% accuracy on the AIM and healthy class, but 67% accuracy on the CAEBV class. Let's see how well these genes predict on validation. Testing set. Prediction AIM. Predicts RF AIM. Testing results. Data. Frame. Predicted equals prediction AIM. Actual equals testing by class. Results. Overall, on this 3-class model, it scored 75% accuracy in prediction. But one of the CAEBV samples was predicted healthy. Okay. Now let's see how well the genes predict. Wow, this is much more wobblier than normal. Than it was before. Now let's see how well the genes predict for the CAEBV class. All right. set.c 1, 2, 3 and train sample, same samples 1 to 17, 0.80% training times 17 samples, 20% holdout test. Training is going to be our CAEBV MX. And train testing CAEBV MX negative in train. Training high. All right, table. Training by class. All right, should be the same. Okay. Table and sampling, anyways, because it's 80%. So, I mean, it should. I mean, not necessarily the same, but I mean, we did set the seed the same. So, just for the numbers in general, that's how the random processor is. Okay, cool. And then let's go ahead, or we could just do a different one. Let's do this different. Let's go 3, 4, 5 and see. See, they changed it up now right there. All right, let's see if it does better. Okay, random forest CAEBV. Random forest. Okay. Training 1 to 20. Training by class M try equals 7 and tree equals 5 0 0 0. Confusion equals true. Importance equals true. Oh, we didn't even check the importance features. RFCAEBV by confusion. Let's see. Oh gosh, 100% accuracy. This was really great in prediction of the class with 100% accuracy in each class of AIM, CAEBV, or healthy. Let's see how well it predicts on a holdout validation. 20% of samples data. Okay, prediction CAEBV. Predict RF CAEBV. Testing results 2. Oh. Okay. Data dot frame predicted equals prediction CAEBV. Actual equals testing by class results 2. Oh, predicaton. Okay, prediction. Okay. Well, it scored the same. Oh, 78% accuracy. That's really good though for a 3-class model. The model scored 75% accuracy for this set of genes. Incorrectly predicting the CAEBV sample as acute infectious mononucleosis. RNA. All right, cool. These seem to be great genes to use in our top genes of AIM and CAEBV. That was a 3-class model, and that score was great for being more than 2 classes. Generally speaking. Okay. So, now we have our mononucleosis data. We can add this to our Tableau data set and pathology, but not today because it's already been 2 hours and 40 minutes. Let's see if it knits. All right. We might come across that same problem that we had before. So I'm going to go ahead and let's search for that eval equals false in all of these. Okay. Okay. Let's keep going because once we start doing this, it's usually because I'll go ahead and put this one right here. For all of these that are doing that. Oh, you know what? Actually, let me just hold on. Let me go through all of this. Okay, that one's fine. Leave that. This could take a while to actually knit. It might work this time, though. CSV. Okay. So each table. Let's go ahead and look at that. And I'll go ahead and read this one in. It's false. But I already have it there, so. I'm going to put eval equals false. Include equals false. Can we read it in, right? Okay. And we already wrote it in. So I can make these ones false. All right, let's just try knitting it. I'll save it, but let's just try knitting it and see what happens. Could take a while. Mm-hmm. 2 hours and 45 minutes. Let's see. I'll leave the link if so. So yeah, I'm just going to edit the details. Nuclear shoulder PBMCs of 1 I'm not sure. uh, the let's see if it knitted it. Execution halted, and it was due to this unnamed chunk 17, so we are having a problem. All right, so I wasn't able to knit it. I'll figure that one out. And then I'll share the RPubs file. I guess I could just do it right now. I have to count the chunks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17. Do we have a normal expression with that CSV in here? Normalized expression. I don't see it. So I couldn't read it in if we don't have it. So we're in this one. Yeah, it's not there. So let's write that one out because it's a val false and I copied it. So then we'll be able to pick up right here. It should be fine. Let's try knitting it again. There it is. Okay. Section 12. Let's see what happens. Oh. Cool. Great. Awesome. Okay. We'll have to update that then. Oh, it looks like it's going along great. We can publish. Let me move this out of the way. I'll go ahead and move this here. Archives. Project on acute infectious mono and chronic active EBV. GSC 89559. All right, what is it? Let's see. Let's go ahead and enlarge this one. And let me get back. Okay. 85599. Okay. 85599. Okay. In this project, we extract EL files on acute infectious mononucleosis and chronic active Epstein-Barr virus. Get top genes by full change, use regex to extract the gene symbol from the platform using the bioconductor package. And then we tested these top 10 stimulated genes by fold change of AIM healthy and CAEBV over healthy. AEBV. AIM. And in random forest classification and found great results, 100% accuracy and CA genes on training and mixed results on AIM training with only 2 classes, 100%, but the CAEBV plus scored 7%, but both in this 3-class model of healthy CAE or AIM scored 75% accuracy on the holdout validation data using an 80-20 training testing data split, like always, like most often. And then we will these to the database and compare later. Other mononucleosis project was with microRNA that we could not use to compare to other associated issues on Tableau. This will be nice to use. Okay. So AIM, CAEBV, GC 85559, 559, 85599. Okay. ML, top genes. Okay. And then I'll go ahead and share this. And I'll put it in here. The details. Okay. All right, great. Thanks so much. We will be working on this next time, possibly tomorrow before work. All right. Have a good one. Bye.